So the exam includes modules 2, 3, 4, and 5. And on module 5, you only have to do up until the questions I list. Like, I think it's page 11. I have a couple extra pages there because they do come up. But really the test is up to page 11. Let me see. Oh, you did the reviews and everything. Great. So the reviews I'm referring to, I'm gonna post the course page. 1 minute. And okay, so I'm going to suppress this information here and all this stuff I put here, and I'll put the exam right under the videos, right? And so the exam is up to here. I have to put up some more questions, but I'll wait till after the exam. Okay, so I'll put up some more. I think I need to put questions up for chapter 14, but I'll do it after the test. And for Connect, I'm talking about. So let's see. So in regression, it's very short, 3-hour review. And the end of last class, I showed you how to easily get the results and interpret them out of your calculator. And I hope that helped because it was much more intense in the review, the 3-hour review. But I wanted you to see the end result. So these are the notes, and I say, yeah, see to page 12. So from pages 1 to 12, page 13 to 18 are extra complimentary for people who've taken regression before and want to link it with other things they know into business and economics. So yeah, it's just up to here. And the bottom here, really, okay, so this is page 9. This is what you need to be able to do. Questions 1 through 9. You need to be able to answer those. And question 10 mm, is related to the next few questions. And so really you need to be good at these and you should be fine. There's a few other questions. But once you do the problems, you'll get an idea of what's expected. So well, let me check the chat. The chat, what do you have to tell me? So you actually guys all got into the review. So not all of you, but so we can look at that. Midterm reviews. It's good, 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 good. So that means that regression wasn't so bad, right? So out of these questions, these 9 questions, did you did you notice that that's the nature of the questions being asked to you, right? Find a residual, um, the proportion of variation is R squared, calculate a slope, interpret the slope, all this stuff here. Okay, so do you want me to do any regression? We think I did. Okay, so I showed you how to get the regression results out of your calculator. I also included, so up to 18 are omitted notes, but after 18 are problems. So starting here are exercises and problems to review. So hopefully you saw that. So these are all to practice, right? And I know I did some of these in the 3-hour video. Uh, any questions about these before? I was going to talk about, this is where we left off. Last class, I showed you how you could get these results out of your calculator. And then for these ones, to get these results out of your calculator, you can get the weighted mean out of your calculator. You know, I can show you how to do this if you don't know. But then the rest, you would use Excel or make a table to calculate because the calculator does not perform weighted standard deviation, weighted correlation. It doesn't make these calculations directly. Um, does anybody want to see this or anything before?
Professor, I don't think the presentation is showing, at least not to me.
Oh, really? I, I,
I see it.
oh, you got to
I see it.
open the screen. Thanks.
I see it.
Mm, move away the discussion or the video of images of us. Can you see it now?
Yes, thank you.
Okay. So yeah, I was just saying, as far as here, so we ended up here. Last class, I focused on this because really that's the culmination of what you need to be able to do. Take two sets of data and see if they're related. And this is what we talked about at the end of last class. This is the case. This is how you calculate the all the statistics for data that are equally relevant or observations that have equal significance or historical data that you don't think have any you know, one is no more important as the other. They're just equally important, in other words. But this kind of data is it's presented in a different way. It's not just a list of historical observations. It's not just a sample, in other words. This is a representation of what we expect. Now, this could be created by conducting historical analysis, looking at past data in a boom state of the economy and saying, okay, that's going to happen with all of our analysis about what's happened in the past and models that we have to predict the future. With 40% likelihood, we think that the S&P 500, which is a measure of the top 500 performing stocks and the return per dollar invested over the period or over the coming period that we're looking at, it's going to return for every dollar invested 14%, which is above average. Average is about 11 or 12 historically. And then this company called BCE, it's actually Bell Canada Enterprises, is going to return for dollar invested to its investors over that period 30% for every dollar invested. So in a normal state, we predict that's going to happen 50% chance that's going to happen. And it's going to be more moderate, 8%, slightly below average. And this is the return. And then with the recession, it's least likely. So this is actually a discrete distribution. This is a distribution, and it's showing there's only three possible states. We summarized everything in three possible states. We used all the economic models available to us that we think are relevant and past historical data. And we came up with this distribution. And with that distribution, you can make you can calculate the parameters because this is a distribution and I'm going to use the symbols, the Greek letters, and you can get first the expected value or the mean, which is a weighted mean for data like this. A weighted standard deviation will calculate the population standard deviation. This is the covariance symbol. So this is not going to go away. I'm going to mention this again in module 6. So you have to get comfortable with these symbols. It's going to come up again. But don't get freaked out because once you get into the symbols, it's much easier. Just remember this like the standard deviation, sample standard deviation calculation we made, but this is not a sample standard deviation. This is actually a calculation of the population standard deviation, because I'm going to interpret these as the three possible outcomes. In reality, you don't just have three possible outcomes, but we summarize the future in three possible outcomes in this case. In fact, there's usually infinite possibilities, and the distribution will have like a certain shape or a form. And like we have the normal distribution, there's other kinds of distributions that describe the future, or model what to expect in the future. Okay, Patricia is without power, but let me know if you have problems making the test, Patricia. I think you're going to be okay because you'll have time to resolve that. That's also another reason why I leave the 3 days to deal with interruptions like that. The test should really take you maybe 2 hours. So even though I give you 3 days, you don't need 3 days. You might want 3 days because you want to be perfect, but you should be able to finish the test in 2 hours. Okay, just to give you an idea, if you sit down, are you going to be able to finish? Just giving you an idea there. So Patricia, you can view the questions and start work. I don't know, it's going to be hard getting all the notes off the platform. If you printed them, if you printed the notes, as another reason, a good idea. You know, we no one wants to use paper anymore in offices and university, but in fact, in Puerto Rico, we need paper because we might not have our power to access digital information. So, I mean, I don't want to tell you guys what to do. I used to not sell the notes. I used to prepare the notes printed for students. But you guys can get it printed out, I hope, if you need to, and use that for the next test or for this test. Okay, so I want to talk about this briefly. What I did was I presented here a table, and I actually shared this table in Moodle. Let me see. I think I did. Here it is. See? Regression statistic formulas, XN. So this is the Excel document. Oh, I have to, I have to project it for you. Okay, so let me show you this. If this is interesting to you, I hope. If you did this already, that's great. Oh, where is it? Oh, okay, so this is it. If you can see that, let me make it a bit bigger. So I have the data here, and I've made columns and formulas using the columns to calculate each step. So if I ask you a question, you can actually copy this document and use the cells. Like so if you copy this document and make a new sheet, and well, provided it's 3 observations, you can just put the new values in here. What is this? Not the data. Where's the data? This is the data? No, where's the data? 0.4, 0.157. Let me double check. One four. Why do I have 147? 1430. 24. Did I change the numbers? I guess I changed the numbers. Okay, so I put different numbers here. Or I'm calculating. What in the world? I'm noticing this. Okay, I'm just going to change them now. Let's go here. So this is the ex post data. And I just changed the numbers. I think I used it for an exercise because these are not the same numbers. I don't even remember. I apologize. But basically, it conducts all the calculations for you. So we're going to put in, if we want to solve from the historical data, we put that data in. If we want to solve using the ex ante data or after the fact, that's what ex ante refers to, I can put the numbers in and get all the results. So I can put 14 here. I don't know what that is. I have all these stray numbers. I'll repost this. So this is 0.14. This is 0.08. And this is 0.04. And this is 0.3, 0.18, 0.10. Okay. And I better write them down because I don't know what happened to this. There's a reason for my badness for sure, but I can't recall. Okay, so there's the data. And then this should carry out the steps, putting the data into the, and step by step. So here I'm multiplying and getting all of the statistics for, or I guess the parameters for X step by step. And I get the sample mean, which is calculated as, right, the sum. So you can see, so anyway, you can download it and you can change the values and check the results, basically. The results are on the solution page. And then here for the variance, we're going to do the square deviations from the mean weighted and summed. And then the standard deviation, I put all the formulas in. And so that's the result. Any questions about that? And the same thing. So all I did was change these numbers, download it and change the numbers. And then for Y, the same thing. The mean, the standard deviation. First, you get the variance and then the standard deviation. And once you have those, you can calculate the correlation. And what do we see? So the correlation is taking the covariance divided by, well, standardized covariance. How do I get the covariance? The covariance is like the variance, except I don't square the deviation from the mean. I multiply the deviation from the mean of both of them. And I explain in the video where this formula comes from. So this is the covariance, and this represents we interpret that to say we'll refer to the direction of the relationship between the variables, and we have trouble understanding the magnitude, like that number. We're not sure what 0.0024 is. Is that high? Is that low? So that's why we standardize. That's why we divide by the standard deviations. And we get 1. So what does this result mean? Well, let me see. What does it mean? And then we'll go back and see if anyone has questions. What does the result +1 mean now that it's a correlation R? What does it mean?
Means that there's a strong correlation between the two variables.
Not just strong, but
It's
perfect correlation. And it means that if you want to make predictions using X to predict Y, in this case, using the economic performance of the market, so the circumstances of the economy to predict what return you'll get for investing in this case, BCE stock, you can do it and you can feel confident that it's good because in the range of these original values, it's a perfect relationship. So as long as you're looking at data or you're looking at situations that where it's between like 4% for the S&P 500 and 14%, the prediction is reliable. And this is probably this is one of the more useful things you're going to see. Well, I mean, everything in this course is useful, but this is, you see a lot of people trying to make a correlation between or draw conclusions about how two phenomena are related. And this is your first step at it, looking for a linear relationship. You begin by making a scatter plot, and if you see things like on a line, this is what you do. If you see a curve, you do something else. Now, Excel has options to look at curve relationships in the same way. I'm not going to talk about it too much in this course, but let me show you that. So I don't expect you to do the step-by-step calculations. Again, for this class, understanding the foundation of statistics is what we're about. And I'm showing you that if you had to, you could do all of this, right? It's not impossible. It's just averages. This is a weighted average, right? The more general kind of an average, not assuming that all the values are the same. They all have different worth or weight. And the average, the square deviation from the mean, or the average of the square deviation from the mean, is a variance. That's another average. So that's what we're doing with the data. And I explain why we calculate in the way that we do. Correlation is interesting for us, or we use it just like we use the variance to get to the standard deviation, which is easily interpreted for us back into the units of the problem, in this case, percent. R is reduced to a number, an index between -1 and 1, and it's easy for us to interpret this. Otherwise, it's not clear what is 0.02024. The only thing that we really know out of this is that the relationship is positive. So we standardize to understand in the range of values of the data that we got, it's a one-for-one relationship. Let's see, what was I going to show you? Okay, so if you wanted to do this, just using this function called core, you actually have a function called core. If you were to use the Excel just to do this, right? You could calculate, I think it's Corel. And then what you do with this is you highlight the matrix of the data. So correlation is just for two variables. So you would highlight, it says array. I don't know if you can see that, if it's big enough. Array sounds like a very mathematical engineering word. But you just highlight these. I don't think you highlight the headings. And where'd it go? There it is. And close it. Uh-oh, what did I do wrong? Something's missing. Okay. I think I have to do one at a time. So like this. You see, I don't do this all the time. Let's see. So, no. Oh, yeah. That's so B6 to B8 and then C6 to C8. I don't recommend you do this because you have your calculators to do it. So, because you kind of get lost. But the formula would be this one. If you're interested. Okay, so that you could get it right away. But I wanted to use Excel to demonstrate the steps. And so how do you use the spreadsheet? You can just enter values into X and Y and it'll calculate everything for you on the spreadsheet. Questions about the spreadsheet? once you have this information, you can calculate the other piece of information. What is the other information you can get from these statistics? The other parameter in this case. I'm calling about parameters because with ex-ante data, we have we call these parameters. Right. So we can get from here the we have the correlation and we can get the slope and the intercept. Wonder if we can get it here. I never tried. No, that's the beta function. No, that's not it. Okay, so we know how to do it, right? So manually then we can get the slope. Let me go back to, so that's what this table is for, to help you just plug in. Sorry. Oh. In case you want a copy of this. Oh, I have it called FINA, honey. This is the one, if you want to do it for the ex post data, you can also do the same. But like I explained to you, this is easily accessed from your calculator. Ex ante, not as easily, even though I think I just said that. You can just get it from your calculator. What you can get from your calculator is this. And I can show you how to do that. Did I show you before? I showed it with the weighted mean. I did show you the weighted mean before. So you enter these values, but on the calculator, you use the arrow going up to get the weighted mean. Do you remember that, or does anybody want me to show that? If not, it's okay. I'll just continue. Okay, no. So let's go to back to the platform. So we got everything on here, all these parameters. The slope we calculate as R sy over sx. In this case, it's rho, the Greek letter for R, for correlation coefficient. And then sy is sigma y. So the y for the standard deviation for the y variable. The variable that the dependent variable is another way to refer to it. And x, the independent variable. So that's what that's all about. And you have that table to work with. And then you go to this discussion over here towards the end where you get the prediction equation. Sorry, close your eyes. And we used it here. We made the prediction. And the prediction line is like a mathematical line. What is the difference? Anyone's going to tell me. What is the difference? How would you explain the difference between the line here that is known as the ordinary least squares regression line? What's the difference between this and a line in mathematics? You can put in the chat. You can tell me. Well, first of all, there's a hat on it. Why is there a hat on it? Well, actually, A and B should also have hats on them, but I don't put it because that's not used at this level in like an introductory course. But these are estimates, okay? These are estimates, and that's what the hat means. Okay, so um so the point is that the line represents the observations here on this scatter plot, but in fact, there are a lot of observations that are off the line. So it's just a representation as of the relationship between X and Y that exists only in the range of the X values. You see, this cuts off. The line doesn't go forever. That's the main thing. In mathematics, the line will go forever. Meaning then we would interpret that, oh, we can make estimates way out here for these values of X. Well, no, you can't. You shouldn't use a regression line to estimate far outside the range of values. It's not useful. And I do discuss that. Well, when we make a regression line and we present it, we are suggesting that the relationship is linear. How strong the relationship is very important. And which calculation do we do to explain the strength of that line or the strength of the relationship between the variables? Which of the calculations represents the strength of the variables? Exactly, Carla, correlation. So the R represents the correlation, represents the strength of the relationship. It also tells us the direction of the relationship. Although we got that from covariance, the covariance and the correlation will always have the same sign. Okay, they'll always tell us the direction. But R gives us more information about how good that line fits to the dots, to the observations, the pairs. Okay. So hopefully you guys did all this. So once you get the R, all of this is possible. First, this is really important. The average for the X's and the average for the Y's must fall on the line. Can somebody explain to me why? If you saw the review or common sense and think about what the average means. Okay, so the line is the least squares prediction line is the line that fits closest to all of the points. So on a line that fits closest to all the observations in the XY space, it must include X bar because X bar is the point or the position or the value that is closest to all the other X values. Remember, X bar is the balancing point. So it's a position that balances the values below it and the values above it. It's the balancing point, center of gravity. And the same for Y. It's the center of gravity in the Y or vertical direction. So that has to fall on the line. And that's really important. Without that result, we can't do the rest. So we know a point on the line. And then we know the slope of the line because I teach you, and I don't derive this, but you can derive this in a higher level statistics course. You could derive this slope is actually R SY over SX. And because, like the example that I demonstrated last class and talked about today with the Excel spreadsheet, with financial data, that's actually interpreted as a measure of risk. The slope is interpreted as a measure of risk. How a move in the horizontal direction influences a move in the vertical direction. Okay, so it's without getting into it too much. So this, I created this acronym here, or this mnemonic device to help you remember the formula, but you don't have to memorize it because you can put it aside and use it for the exam. But I used to teach, and students had to memorize it. So I gave them this tip to memorize the order SY over SX. All right, so you have a slope and you have a point. When you have a slope and a point, or when you have 2 points, that's enough to draw a relationship called a line, right? We can make a line. To make the line, we need to find, to make the equation of the line, we do it this way. We put the point and the slope into this equation. Basically, we insert the y and the b and the x using a point and a slope to solve for A. A is the y-intercept. And we do the steps here, and I make the calculation. I was very precise here, okay? Yeah, very precise, and that can be complicated, remembering all these decimals and keeping it all. But usually you follow the directions on the test about how to do it, but you'll see in the end you have to pick a multiple choice option. So I'll be rounding these, But to be precise, keep all your decimal places, and it's like this is the relationship. So then I go through in the notes and talk about the relationship, interpreting the slope, interpreting the y-intercept, and for the slope, it's okay, 1.204. What does it mean? I'm going to round to 1.2, and I interpret it as, okay, I'm going to put on my iPad. Is this okay? I'm doing a little review. Or are you guys waiting for me to do the numerical reviews? I'm almost done with what I have to say. See if this, are you guys okay? I'm almost done here. All right, so we said that the slope B was found to be 1.2. 1.2, think about it like this. And this, as you learned, if you vaguely recall from high school, this is change in y over change in x. That's what the slope is. So how we're going to say this always is say, so I put this 1 here, okay? We can understand there's always a 1 under whatever value. So for a 1 unit increase in x, y increases because it's a positive 1.2 units. So in general, that's how you can read it. You can plug in this value, but that's in general the statement. For a 1 unit increase in whatever the x variable is, y increases 1.2 units. Now we could put in the word units. So in our case, for 1 unit increase in, so you could say for each additional millimeter, you can say y. So in our case, y, so I'm going to wait, let me go back. Each millimeter of, what was the x variable in this problem? The x variable was called, was it the humerus, right? No, femur was x, okay. For each additional millimeter of the femur, right, the femur, so the leg bone, the arms are longer than the legs. Ew, insects, right? So for each additional millimeter of the femur, the humerus is 1.2 units longer. All right. Longer. I said larger in the notes. So that's the slope interpretation. And, you know, it's a slope. So it's, if somebody asked you, what about if the femur is 10 units longer? The humerus would be how much longer? So for every unit, y is 1.2 longer. So if you have 10 units, how much longer will y be? Right, 12. Very good. Okay, so you just multiply. Basically, if I had 100 longer, this would be, y would be 120. All right, so it's, I can even just do 5 longer, and then it's going to be what? 6, not 50. 50? No, it's too big, too big. 6. So what you have to do is just multiply both, right? 5 and 5. That's what I'm doing. So it's a proportional relationship. That's what a slope is. Good. That's how we use it. And then once we have the slope, we're going to get the y-intercept. And I do a review of, if you don't understand what I'm talking about, go and watch the review of lines to see that. So the slope and then the intercept. So this is the slope. To get the y-intercept, then you take the equation y equals a plus bx, which is the standard equation of the line, and you plug in what you have. What do I have? I have x bar, y bar, and I have b, so I put all those values in. As long as I have a point and a slope, I can do this. If we have 2 points, we can also do this, but we're using the slope to do it. So it's either way you can get the equation of a line, 2 points or a slope and a point. In this class, we work with the slope and the point. So you put everything in and then you solve it and you find out that a is like negative. A is, no, sorry. Yeah, negative 4, negative 4.11. You have some different values there because I kept more decimal places. Oh, I just noticed a typo there. But okay, let's just say negative 4. Okay, it's not, I have it also precise in the notes, but negative 4. So what does negative 4 mean? Let's put it in the equation. So it, once I get back to the statistical equation of a line, so I write it like this, and it means that when x is 0, so when I put a 0 here, y is negative 4. It means where it tells me where I cross the x-axis. X-axis This is a terrible drawing. Hold on. I'll do that again. Get my ruler out. This keeps going down there. So it's going to be so the line's going to cross through. This is x equals 0 is the y axis. So it's going to cross through here. That's all it's saying. And I know that it goes like this because the slope is a positive. And then the point that I make about this the point that I make about this is that it's weird, right? Because how can you have the variables x and y are both millimeters. How can I have a measure over here with a negative? Doesn't make any sense. But again, that's stressing the point that the data is over here. The data is not down there. So you don't interpret outside the range of the data, which is like over here somewhere. Actually, it's way over here because I'm in the 40s. What I did was I just put a break in the, I'm not starting exactly at the axis, but if I'm going to interpret like at the axis, this would be over here because these numbers are 40 to 80. Anyway, they're larger numbers. Okay, so you don't draw the line, you don't extend the line out. All right, so that's called an extrapolation or extrapolation. If you do that, and you shouldn't do it. See, I'm going to put it in red. You shouldn't do that. Okay, so that is that. And then I talked about a residual calculation and the coefficient of determination. And you should be able to do all this stuff. Okay, so any questions? So let's go through now the questions you have. Give me a list of the questions. I think you wrote them in the chat, right? Some questions you want me to look at. Let's take 5 minutes, come back. Let's take 10 minutes. Come back at 10 after 10. And I'm going to make my list and go through the list of questions that you have. I'll make a list with the questions you wrote me here. Okay, let's take 10 minutes. My writing is so bad. Okay, I'm back. You can see, so these are the these are the problems that I listed from the reviews. I thought I had another email though. Well, I have one from Diana. Oh yeah, that was 25. And I'm pretty sure I had another email. Am I missing anybody's questions? So these are review 1 and review 2. Exercise 2. One number 9. 2 from 1. Okay. 3 and 9. Okay. I don't know. I hope I have everyone's. I can't find the other email. I'm gonna check my text. Oh, okay. So I hopefully I'm getting everybody's question. There was nothing in the forum. I did not have a notification in the forum. Okay. 2 from review. Okay, let's see. I'm going to demonstrate the reviews. I have to do question 2. Oh yeah, this one. Okay, yeah. So somebody wanted that one. That's right. Okay, so this is an interesting one. Let's see how I can do an explaining, okay? Let's see how I do. If these are all the questions that you have, like these challenging one, that's a good sign, okay? It's not hard. It's just something you feel limited with the tools you have to do this one. So the distribution of weekly salaries in a small company with 19 employees is such that the first quartile is 500, the third quartile is 1,100, and the range is 100. Okay, so this is a value point that we have. This one is as well. Between this one and this one are 50% of the observations. And it tells you that the range is 1,000. What is the range? The range is I don't know why my pen is so thick. We'll try that. Oh yeah. So range is equal to the maximum minus the minimum. Knowing Q1, Q3, and range, which is the maximum minus the minimum, can we possibly know the mean and standard deviation? Is there any way? These values are, they may or may not be actual observations. And they do not necessarily tell us any of the values. We just have, this might not really even be a value. It won't even help us making a calculation like a mean or a standard deviation that uses all the values. So we can't possibly get any of these. So these are all eliminated. Okay, very tricky. But anyway, you can't calculate these from the information that's given. All right, you need all the data to do X and all the data to do S to make a calculation of either of those. So that leaves us with the median as 800, or the maximum is between 1,100 and 1,500. And what it's toying with here, I believe, is that the third quartile could be the maximum. How could the third quartile be the maximum? All the values, the 25% the top 25% of observations are all 1,100. That's the way that it can be a maximum. We do not have enough information to get the median. Why don't we have enough information to get the median? Think about what the median is, right? The median is found as the n plus 1/2 observation. Now we know 19 is n, so it's 20/2 is, but do we have all the observations to count the 10th observation? I really don't know, right? No, so we don't, that's, so basically break down what you have and realize we don't have all the data to calculate these. We need every observation to get these. We can't even estimate it because we don't know. We just know elements of the 5-number summary. That's all we have. So by process of elimination, it's E. But let's talk about E a little bit more, so you feel more confident. All right, so the range is max minus the min. It has to be 1,000. Let's put that together. So this has to be 1,000. I have no other data. And I just know I have 19 observations. Let's say in the extreme, it could be Q1 could be, sorry, the minimum could be lower than Q1, but let's just say if Q1 was the minimum, that's 500, and the range must be 1,000. This means, or this implies, that the maximum is equal to what? 1,500. Very good. Say the maximum is Q3 or 1,100. And again, since the range hold on. No, I only have to care about the maximum. So I'm not going to say this. Okay. I don't have to do that. So, so the minimum, so this is the most the maximum can be. The minimum that the maximum can be is Q3. Remember the 5-number summary, right? It's going to be minimum, Q1, Q2, Q3, max. So this creates and this is in numerical order, so this creates like a threshold, right? So Q3 is 1,100. So that means the maximum must come after that. But they can be the same. Okay, so this is the piece of information that I have to give you. And there's some more problems like that where Q3 can be the same as the max. So the lowest the max can be is 1,100, the lowest, but the most it can be is taking the actual max, no, sorry, taking Q3 and adding the 1,000 to it. No, taking, what did I take? I took I took the lowest value. So, okay, so I'm saying two things that, so either the point is here that the max can be or can be Q3, but also the min can be Q1. So using that twice, first, I say that using the minimum as Q1, it's enough because I don't have the data, but I'm trying to find a range. So the minimum is Q1, that's the highest, otherwise, the highest that the minimum can be, but it could be lower, but the highest that it can be is 500, and I make a range from there. So that will give us up to 1,500, but the lowest it can be is 1,100. So basically that was the information I give you. I'm adding to your knowledge set. Basically that the minimum can be Q1 and the maximum can be Q3. And with that information, you can calculate that the lowest maximum can be 1100 and the highest maximum can be 1500. Is that okay for people? Let me know. That's not easy. It's not easy when you're starting to learn, but now you know, okay? So that's the new information or there's nothing really, anyway, I guess I just have to say that explicitly, but it's implied. And I do have some examples like that. And I think we did see one like that, or maybe we didn't. So the box plot can be like, and in this box plot, Q1, Q3 is equal to the maximum. You see? I don't draw anything else. Or this is the number line here. Or if I have one like this, so let me go through this. So this is the min. This is Q1. Q2 is not even drawn. I could do that too. Q1 and Q2 could be the same. And Q3 and max could be the same, but I'll draw a median there. Okay, so here the minimum, Q1 and the minimum are the same. It just means you have repeating values, a lot of them. And that's not unlikely. If it's a test result and a bunch of students failed and they just got a low mark or 0, they're all down here together, bunched together. 25% of the observations. Okay. All right, let's do the next one. My list. Where's my list? Okay, so we did number 2. Let's look at number 3. Considering the observations, the range and the interquartile range are respectively, okay, for this one, just put them in order. They're not in order. That's the problem here. That's the kind of like the trick. So if you put them in order, -2, 0, 1, 2, 6, 8. So the range is equal to the max minus the min is 8. Be careful, minus -2, right? Because it's further away. It's even 2 more away from 0. So that's 10. So that lowers you to B and C. And the interquartile range, Q3 minus Q1. So what I'm going to do is divide up the data. It's in order. So that's going to be the median between those two. This is Q1 and this is Q3. You see that? And this is min. And this is max. It's very easy to do with a small data set. So Q3 minus Q1 is 6. So Q3 minus Q1 is 6 because it's 6 minus 0, which is 6. So the answer is here. How's that? So you might have messed up either. You didn't put them in order or you didn't do minus minus 2. I think those are the ways to mess up that. All right. Good. Now let's go to 9. these drawings, these drawings. Make it bigger. Okay. So they have 4 descriptions and 4 histograms, and you have to match them. So this is showing continuous data. And this is just count data. These are just bars like either on observation is a low number or it's a high number, but there's more low. And similarly here, but in this case, there's more of the high number. So read through these and tell me which one are discrete, right? Just certain values, they're discrete, and which ones are continuous, and that can help you a lot. So let's see. Let's write it down. The gender of this, so these are both continuous up here. And these are discrete. So they're quantitative, discrete, or also this can also be considered nominal data. Oh, they say they're histogram or bar graphs. Oh, okay. So it can also be nominal. Let me fix that. Okay, because it says bar graphs, not just histograms. Histograms would be for continuous data. All right, so the gender of the students in a class having somewhat more females than males, and male is 0 and female is 1, and there's more females, so more ones. Which one would that be? More ones. There's just 2 observations.
D?
It looks like D, right? More females. It says somewhat more females. I guess it's somewhat. It's like double, but somewhat. Okay, so this could be D. The heights of students in a certain class. So this is a continuous variable. So these are both continuous variables, these ones. Continuous. Right. And this one, income. So let's see which one of these is the height of students and which one of these is the income of a group of lawyers. Well, that's probably the easiest one because we know that pattern. What's the pattern of the income of a group of lawyers? Income in general is right skewed. So which one is it? Yeah. It's not extremely, but so, lawyers most of them make like this kind of amount of money, but there's a few that make a lot and they're stretching this out to here. So a few of them make a lot. So that's going to be A. And what do we have left? The height of students in a class would be the other one. So that's going to be B. And that leaves the left-handedness of students in a class recorded 0 for right hand and 1 for left hand. So there's very few left-handed kids. Let's see. All right, so we have in order, A is 4, B is 2, Roman numerals. C is 3, and D is 1. I get B. Good. Okay, so we did number 9. Let's go to 19. Any questions about this one? So sometimes it's just process of elimination, the obvious ones, and then the ones that you don't know so well will fall, well, they'll just fall out. Or they'll present themselves. You have to decide. Like in this one. I anchored myself with the fact that income's a group of lawyers is slightly, right skewed. $19. Oh, I like these ones. Let me get my list. Okay, let me make it bigger. Nice. All right. So I made a series of scatter plots in the notes. Sorry, they're all crooked. I made a series of scatter plots in the notes back in module 3. And now we're going to use that skill, right? So we calculate correlations, negative 0.95, 0.02, and 0.67. Now, which is which? The negative is only one negative. Which one is the negative one?
The A?
That's right, because it's going down. The higher A is, sorry, the higher the horizontal variable is, the lower the vertical. It's going down. So this is negative 0.95. And now you get to choose between these two. Which one is closer to 0, R? B or C? Right, because it's flat. If I try to fit a line close to all the points, it's going to end up like, if anything, like, very, very flat. But positive. It looks positive. All right, so I don't know why I wrote B here. This is RA. RB is equal to the other one, 0.76. And the one close to 0 is RC.
Professor, I'm sorry. I don't understand how you got to that.
Oh, the result? Okay, start back, go back. From here, okay, RA is negative, so we take the negative one. And it's
Right.
very close to -1.
Right.
And then from these two, I'm looking at the line that fits closest to all the points. And that
Right.
one would be there, and that one would be there. And the correlation means the fit to the line, right? So they're both positive, and that's what these both are. But the R tells you how close to the line. Which one is closer to the line? B or C?
B.
Exactly. It's
So that means it would have the higher number if it's closer to
exactly.
the line.
Yep.
Okay.
For the R. It's closer to the line. RB will have the closer to 1. It's closer to the 1 than 1 to 0. Okay, because it's positive, it's closer to 1 than it is close to 0. But this one is closer to 0 than it is to 1.
When you say that it's closer, you mean like the amount of dots that the line is touching?
No, I mean that the value R is closer to 0 in this
Okay.
case. It's a good question. Closer to 0. So how we calculate a R of 0.02, go back and look at how we calculated it. I explain it in the, well, if you didn't have a chance, you're going to watch the 3-hour video on regression, and I go through step by step explaining it. You have time. You can review that today if you didn't have a chance. So R tells you how close, how strong, strength, tells you both. R tells you about the direction, so it'll be positive or negative to tell you the direction of the relationship. But it also importantly tells you the strength of a linear relationship between two quantitative variables. Okay. So we pick, it's going to be C. Yeah, good. All right, let's see what else we have here. So we're done with review 1. Are there any other questions? I'm only up question 5. Do you want me to pick some other ones for you? I'm only on page 5 of review 1.
Professor, I have a doubt. The normal distribution table is going to be in the exam, or can search it in Moodle for.
Yeah, you get it in Moodle on your notes. You can
Okay,
print it.
perfect. Thank you.
Yeah, you should print it out.
Okay.
Any other questions from review 1? Do you want me to pick some off? The module 2 is at the end. These are all module 2 questions because the course used to be taught like that. But it makes more sense to teach data collection methods and experiments and sampling at the beginning. So anyway, so these come at the end. All right, so you guys are good with that? Let's go to, oh, let me get my list. So I have to just do 16, 21, 22, and 25 on review 2. And then I'll let you go. You guys you want to go study? Just good. Good. All right. So I have to go to 16, 21, 22. Uh-huh. Suppose that X is normally distributed with a mean of 0 and standard deviation of 5. Okay, so to do this problem, are you sure it's this one you want me to do? The exam will be open for 3 days and you have 3 days to go in and out and change answers, and don't worry. I'm just suggesting that it shouldn't take you more than 2 hours in time total, but don't, you can use up to 3 days. That's to account for people who need more time, or people who are traveling, or people don't have a set amount of time that they're going to go in and out. So what was I saying? So X is distributed normal with a mean of 0 and a standard deviation of 5. What is the probability that X is less than 5? So you have to take, in this problem, you're going to standardize and convert X to Z, taking 5 minus the mean divided by the standard deviation, which is the relationship between Z and X. Z is the number of standard deviations from the mean, and you can create it by doing this calculation. So we convert X into a Z. I call it Z because in Canada it's Z. It's Z as well. And so that is, I'm Canadian. Sorry if I didn't fill that in. So 5 minus 0 over 5. So that's Z less than 1. And you can look it up, or you can remember the fact that 68% of observations are within 1 standard deviation. Of the mean. So then we can draw it. So like we can just go to the table, but I'm going to just remind you that if I'm here, this would be 68, but then this other side would be 1 minus 0.68 divided by 2, which is 16. Remember all these numbers? That's 16%. So this would be 16 and this would be 68. And if you add them together, you get 84. So the answer should be 84. But now let's go look on the table to do that. If I look up 1 on the table, let me get my table. I should be 84 something. See? $84 something. I just showed you that a lot of the exercises in the homework and many of them in the exam are very easy to calculate. You don't need the whole table, but I'm giving you the whole table in case. So when I was a student, I sorry, where'd my exam go? Oh, I guess this is it. Looks so different. Okay, so when I was a student and I didn't have a answer key, I approached problems trying to solve them 2 different ways. That way I could confirm my answer, right? So this is going to be 84 to the left. Approximately, if I go to the table, I get the same answer. So the answer is D. I hope that's the answer in the solutions for someone to ask me that question. So 16, and what else? Where's my questions? 21, 22, 25. Okay. Let's do 21. It's a long one. Can you read that? Is it clear?
Yes.
Do students who miss more classes get lower grades? Suppose that a random sample of 15 students, statistics students, is selected, and that the following output is obtained from the regression of final exam score on number of classes missed. And just to clarify, how do I make a scatter plot? The first one is always the Y. And then we say on or versus the X, okay? If you didn't catch that somewhere, I'm pretty sure I mentioned it in the videos. So this is a negative relationship, but it's moderate. It's good in terms of the strength of the relationship. And I can see that here's the R square in the output. The R squared, what does the R squared tell me? So you got to go back to the definition of R square. So R, I defined R just now, but what's R square? R square is just the R squared. Or let's write it like this. Let me say, we call it like R squared. And it's interpreted as a percentage. The percentage of variation in Y that is explained by X. And it can be between 0 to 100%. That's how we interpret that, or that's how we use that number. So it's no longer a 0 to -1 like R was. It's 0 to 100%. It's a different unit percentage. So the options here are, oh, so I didn't finish. So R square was equal to 0.5952. So what is R? If R square is 0.5952, what is R? Square root. But no, you have to put the negative here. Why do I have to put the negative here?
So that it's a positive
Because,
number.
because the slope is negative.
Well, because I lose, when they square it, they lose the sign. So when I take the square root, I have to put it back in. Now, it's not always negative, but it's going to be a negative for this graph. All right, so you need the graph to see that, or you need to see the slope here. Remember, the correlation and the slope have the same sign. So you know it's going down. It's negative. So that's why I have to put that there. And then I can calculate it. Zero 0.7715 negative You don't have to do that every time, but just keep that in mind. Though it's a higher number, like in terms of R squared, because you're always squaring a decimal value, it's always going to be smaller than the R. So let's go through the options here, if they even ask us that. So since there are no students in the sample who missed exactly 8 classes, it would be inappropriate to use the regression line to predict the final score of a student who missed 8 classes. So let's see if that's true. Oh, so there's no dot where they missed 8 classes. All right, so we have like, so this is like 5 classes, this is 10 classes, this is like 7.5, so 8 would be like here, right? So there's like nothing there. You know what I mean? Because this is half, so this is like 7.5. So this is 7, and 8 should be on this side. So there's no 8 classes. So let's check back with the statement. Is this true or false? True or false? False, right? Because it's perfect. It's perfect to make a prediction with this line that's rather, moderate. It's moderately strong relationship. It's negative. And to make it at 8 is good because it's in the range of data. So that is false. It's false. Let's go to the next one. For a student who misses 30 classes, a good prediction of his or her final exam would be 7.18. False or true? True or false? False, right? Because we could take 30 and put 30 in here and calculate like 30 times, that's 60. Okay, so they get 7. So they just plugged it in here and got this number, but you can't do that for a value of 30. It's way out of the range of data. It's not a good idea. So I'm going to say false. Okay, the predicted final exam score goes down by 2.64 for every class missed. So remember what the slope is. The slope is equal to the change in y over change in x. And if it's negative 2.64, you put it over 1. And x is missed classes and y is final exam. So for one missed class, your final exam score goes down for the negative 2.64. Is that what it says? That looks good. Right? That's a true one. Let's just continue for sake of practice. Based on these results, we can conclude that a student will increase his or her score on a final exam by attending more classes. What do you think about that statement? Ah, careful, careful. Correlation does not mean causation. So you got caught, even though that feels confident, comfy, like a comfortable interpretation. You got to be careful because it doesn't, it suggests that maybe, but that a student will increase his, it's too strong of a statement. So this is, yes, people do that. People look at correlations and draw conclusions that if you want to go be up higher with higher grade, you need to miss less classes. But in fact, this could just be an association driven by other things. The people who are missing classes might be missing classes because they are otherwise occupied, they can't make it to class, they're working, other reasons, right? It doesn't mean that you're going to do poorly if you miss classes necessarily. I mean, I want to discourage you from missing, classes, but in fact, this is just a correlation. Correlation does not imply causation. But obviously, there's something to be said to be investigated here. Do you understand my point, everyone? So it looks like a tendency, but you can't make strong statements without other information. If these students all had the same circumstances and the same aptitude, yes. But maybe students who miss class, they're missing class because they feel frustrated and they're not understanding and they don't want to feel stupid. They don't come to class. But if you miss class, that wouldn't happen because you do all the extra work on your own time and you'd pick it up and in fact, you're very efficient. That's why you're multitasking. So it doesn't necessarily mean you. All right. Lurking variables, Jordan. Exactly. There's other things behind that are leading these students to do poorly that has nothing to do with the class. They have other factors. All right. Very good. Based on the equation of the regression line, we predict that a student who doesn't attend any classes will receive a final exam score of only 2.64. Aha. So this is an interpretation of nothing. A student who doesn't attend any classes. So they're just misinterpreting. If a student doesn't attend any classes, so you'd have to know the number of classes total. So maybe maybe there's see, I need to know more here about how many classes there are. So that maybe there's 30 classes. So that would be an extrapolation if they put 0 here and calculated this, but that's not even what it did. It's just misinterpreted that slope. So this is no, it's false. That's not what the 2.64 means. The 2.64 is C. So this is the right answer, C. Good. Almost caught you there. Okay, what do we have next? Where's my list? So 22, 21, I think 22, and then 25. Let me see again. Yes, my memory. 21, 22 is about the same problem. Something happened here. Close. Okay. 22 and 25. Okay, one student missed 2 classes and received a final exam score of 84. What is the value for the residual? All right, very good. We get to make a calculation. Let me move this problem back to the other page. I'm going to do it like this. Can you see that? You know what I got to do is make the whole thing bigger. Making myself crazy. So one student missed 2 classes and received a final exam score of 84. So that's an observation. It's just telling you someone missed 2 classes with this person here and got 84. Where is that? Okay, this is supposed to be 2. This is supposed to be the value here, I think. What do you think? Yeah. So that's what we're talking about. And so we're going to calculate the residual. Now we actually have the graph. You might not always have the graph, but what will the residual be here? Positive or negative? According to the graph and the point that I picked out. Residuals on top are always positive. Residuals for values or observations on top will be positive, and for observations on the bottom of the least squares regression line will be negative. So let's just look out for that to confirm that it is in fact that point. So how do we calculate a residual? The residual is calculated as the distance from the observation to the line. How do I know the values on the line? I use the equation. So let's take the equation here. Blow it up. Clean it up a bit. Okay, so let's use this equation. What we're going to predict is the effect of 2 missed classes, right? This is the predicted value. I'm going to erase this calculation here. Get that out of the way. So this I'm going to call Y predicted, or I'm going to use a hat. So 86.39 minus, now you multiply that by 2, and that's going to be like this. Is that right? $81.0. What did I do wrong? Did I do something wrong? 2.64 times 2 plus 86.39. Why do we have different? Christina has the right answer there. Carla, check your numbers. 81.11. And to calculate the residual is calculated as Y observed minus Y predicted, always in alphabetical order. LMNOP. Statistics is in alphabetical order. I started noticing that pattern and it helped me a lot with reading statistical textbooks. So they subtract where the observed is up here and the predicted is on the line, right? So then the observed is, well, given to me here. This is Y observed up here. That's what they tell you. It was received. Okay, they didn't say observed, but okay. 84 minus 81.11. So the residual is positive, like I promised it would be if I drew it right. And the residual is, see how they trick you? They put the predicted value there. Don't get tricked. 84 minus 81.11 is 2.89. So that rounds to 2.9. Got it? That's question 22. I think I've done a little bit of everything so far. If you feel there's gaps, go back and watch the video instructions of the lectures because you missed something. Because I don't talk about everything in our meetings. Our meetings are just review, overview and review. And you don't have to come. You only have every time you can come 5 times. Some of you have already come 5 times. Some of you will keep coming. I'm happy to have you. I don't like talking to myself. It doesn't feel right. Well, it's nice to have students here. Now let's do 25. I'll give you a minute. Sorry, it's so crooked on the screen. Hope that's all right. So it's observed minus predicted is the residual. We could subtract the other way, but then we wouldn't have the result that the above the line values have positive residuals and below the line value have negative residuals. So we subtracted observed minus predicted. Okay, so let's do 25. Okay, so I'm going to take the question over here. 209 students. For 209 students, the following is a scatter plot of the students' heights versus the span of the student's writing hand measured from the tip of the thumb to the little finger on the spread hand. Wow, what a description. So that is called the span. It's like making the loser L. I don't know. Why am I thinking about that? But, you know, it's like making that L with your fingers. And the correlation for this data is R equals 0.6, and the equation of the regression line for height on span is that prediction line. So they're giving you the line that goes like through here. Notice the axis does not start at 0. Okay, so this can go like that. I know I'm not supposed to extend things too far, but the line will show the intercept, right? If you extend the line, but it might not be meaningful because it's far away from the data. Okay, so let's see for 25, what does it say? Oh yeah, this one. All you need is that. All right, so why don't you try that? So, if the unit for measuring is changed to, what does it start with? So, oh, from centimeters to inches, how will this change? So this one is in centimeters as well. And you're correlating student height and span. So they're both in centimeters, but if I change this graph to be inches, what will change? The slope, the intercept, or the correlation? So correlation is an index, right? You're taking the covariance of x and y and you divide by sx and sy, which ends up being, if this was in centimeters, and I demonstrate this in the beginning of the notes, that if you have, you know, some number here in centimeters and you have, this is going to end up being squared. I'm going to say centimeters square, which we don't use, remember? And then this is going to be centimeters times centimeters, which is centimeters squared. Those squares, some number, the units will cancel, right? The centimeter squares will all cancel. And you'll just get an index that's between -1 and 1. So R won't change. R won't change. So any of the ones that say R will not change. So this one is out. The equation of the regression line will change. So what happens to the slope and the intercept? The slope is R sy over sx. So the slope shouldn't change, right? With the same logic. It shouldn't matter the units. So I hope you guys are following along. So if I made a different graph with the inches, the R won't change because it doesn't matter about the units, because you would adjust all the numbers on both top and bottom to be inches, and it doesn't matter what the units are. It's not going to change R. And then here, the slope we interpret as change in Y over change in X, but in the same way, it doesn't have units either, right? if they're the same. I think that's the point. That if they're both centimeters and now they changed both to inches, shouldn't change. But A, which is the intercept, is a value. And I estimate it, or I calculate it as y bar minus bx bar. So it's going to be in the units. It's not going to be. So anyway, I'm just doing this from first principles here, but I think the answer is different. Because the answer says it's D. Oh no, wait, only the slope will change. No, it should be the intercept. No, I think that's only the intercept, both the intercept and slope, the equation line, correlation. Why am I stumped? So what do you guys say? The slope and the intercept. The slope and the intercept. The slope will not change. Span. Well, anyway, let me see, because I think some of these questions, if I recall, questions like this, some of they're inconsistent, and it might have to do with the fact that the units have to be the same. It has to be the same units. X and Y have to be the same units. And then in that way, they'll just cancel out and it won't affect R. It won't affect, because it's not necessarily two. You could be correlating two different things. Like one could be height and one could be weight. Those are different units, right? But if they're the same units, correlation won't be affected. The B shouldn't be affected, and it would just be the intercept. But that's not what it says here. So anyway, the test won't have a question like this, so don't worry about it. But I will sort this out for next class. Okay? The test doesn't have a question like this. Wouldn't just the correlation remain unchanged? Well, I'm like, if I'm going to use the same logic that I used here for R, this wouldn't have units either, right? Because it's this has no units, and then SY would be in centimeters and SX would be in centimeters, so they would also cancel. But the ratio might be different. I don't know. I'm missing some information here. Conversion. Wouldn't just the coordinate, because the magnitude of the slope changes due to the unit conversion. But look what I'm looking at here, Jordan. Like I'm eliminating units. So it looks like it's just the intercept if I use that logic. But anyway, I'll look at that and I'll get back to you. Don't worry, this won't be on the test. All right. Why I have because I do think that there's some answers that are inconsistent when I ask this question, and you might have noticed that. All right. Any other questions? Uh, 26. Is that the same problem? All right, let's do 26. What percentage of variation in height is explained by the regression of height on the spanning? So this is exactly the definition of, so height is Y. So, height is Y and span is X. Always do that, like when you see the words, just Y and X. So this is the definition of R square. They're asking you what is r squared. So you got to go to the problem. And do we have r squared? Oh, we have r. So you got to take r and square it. Which one is it? Oh, it's none of them. Oh my goodness. It's very rare. Usually the answers are correct. So the correlation is 0.6, 0.6 squared. Is that why you're asking me? Oh no, okay, it worked, sorry. I got 0.36. C. Yeah. Anything else? So that's the definition of, that's the statement r squared, the percentage of variation in y explained by the regression of height on the span of handwriting. It's on X. I guess it's another way to say it. Just another way to refer to r squared. Okay, so I'll stay back if people have questions. And then the exam will open at 1 o'clock. The exam will open at 1 o'clock for you. Okay. Anything else for me? I'll stay back and I'll stop the recording. So good luck. I'm stopping the recording.